This is going to be an interesting section. This is section 10.5, which is talking about abuses of statistics. And even more than you understanding mean, median, and mode and all of that good stuff. I mean, that is important that you know because you are going to be asked to read reports and to look at things that have statistics in them. So it is important that you understand where those things are generated from. But I really think this is the most important section of this entire chapter, and that is abuses of statistics, because we are misled every single day with statistical data. you know we need to be aware of what we're told in the news or on commercials. You see them say that that 90% of dentists recommend so and so toothpaste, and 75% of people thought this, and the presidential approval rating right now is at such and such percent. Well, you have to be so careful. People lie with statistics all the time. They use them to their advantage and to make a case for whatever it is that they're selling. And that might be a product or it might be information. You have to be careful. Every time I see statistical data or some sort of a census thing, talking about populations and what people think, and certain percentage of people thought this. The very minute I see that, I start questioning it because I don't believe it. And that's because I know a little bit about statistics and I understand exactly how people skew the statistics in order to show what they want. So I have just a little story here that I wanted to share with you. You have to be so careful. When I was in Comp 2, when I was in college, I did a paper about women in the military. And it just so happened that my sister was a Marine at the time. And so I was able to interview her commanding officer and some people that she worked with, and then I also read a ton of research articles and regular articles, that would appear like in Time or USA Today or whatever, but peer-reviewed research articles, different books, whatever I needed to get a good picture of what was going on. And I got so upset because, everything at that time was saying women should not be in the military. And the main reason that they all gave for it had absolutely nothing to do with, men not being able to control themselves or to be distracted in battle or whatever. The main reason that I kept running into over and over and over again was pregnancy. And they would say statistics that were just mind boggling. They would say things like 50% of the women in any platoon at any time could be pregnant. Well, my goodness, that just makes you think, you've got, hundreds of people or however much in a platoon. So, my goodness, that must mean that, all of these women are pregnant. Well, what they failed to tell you, though, was that there may only be two women in that particular platoon. So if half of them are pregnant, 50%, that really only means one person is, which when you put it like that, sounds a whole lot different than whenever you say 50% of anybody in a platoon. That makes it sound like it's a huge amount of people. So I ran into this, and I learned very quickly to be very, very careful about statistics. You need to have some background information. Otherwise, you just flat don't believe them. Period. It's so much safer that way. So we have misuses of data based on samples and population. And these types of abuses, I wrote on here, of statistics happen all the time. And it's because our sample size is too small or the entire population was not really represented. Things like, bad sampling, taking, if you're just, sitting there and whoever you happen to run into that day, you ask them a question. That's a bad sampling method. You're not really getting a true representation of the population by just getting people in one location. That's a very small part of the population. Um, there are, all kinds of ways that people mess up the statistics, and they could just be flat out biased to begin with. And they could ask a question, like, do you prefer a piece of chocolate candy or a cool, refreshing Coca-Cola? See, when you put it like that, people start getting in their mind this cool and refreshing might sound so much better. So they tend to make choices based on how you've phrased the question. So you have to be careful about that too. So I wanted to put out here a few things that are extremely, um, just red light flashing for me anyway. This one says 82% of the parents surveyed say that there is not too much focus on preparing for tests. Well, test preparation and stuff has been very important in school and very high profile lately, so this is very relevant. Only 9% of the parents say that learning is thwarted. What? Did Were people asked that specifically? Were they asked, is learning thwarted? It makes you wonder, do people understand what that word means? I mean, are you asking people that are fully capable of answering the question? Even with the first one there, what is your sample? Who are you talking to? 82% of the parents surveyed said that there's not too much focus on preparing for tests. Did they survey 8 people? If they did, then it sure didn't take very many to make 82%. You're talking six or so are going to make 82%. So, um, not that impressive. When you say 82% of parents, of the parents surveyed without telling how many were surveyed, it makes it sound like a much grander scale than what it really was. So be careful and don't fall for that. 12% of the parents say test questions are too difficult and that expectations are unreasonable. Again, what's the sample? How were these questions asked? Were they asked, in that manner that of questions being too difficult and expectations being unreasonable? Those are a little bit bias-seeking words. So, you have to be so very careful that you're not asking questions in such a way to get an answer the way that that it in order to skew your statistics. Whenever you go in to do a research project or something, everybody has biases. That's true. You just can't get around that. But you have to be so very careful that your data is whatever the data is. And if you're proven wrong, then you're proven wrong. And you just go on. So, but a lot of people, especially in the product selling business and the people selling business, don't follow by those rules, and they intentionally will tell you things making it sound a lot better or a lot different than what it really is in reality. So don't fall for it. At least 89% of the parents believe that schools require too many tests. Well, I mean, that could very well be. How many parents did they survey? How did they ask the question? The vast majority of parents say that teachers are not putting too much academic pressure on their children. Exactly which parents were they asking? Were they asking a nice sampling of, different socioeconomic groups? Were they asking the kids that were, all of the very popular kids, the prominent people in town's children may treat them differently than somebody from the wrong side of the tracks, so to say, or something like that. So their parents' perceptions could be corrupted just by who and what where their children are. So my I have a lot of questions about these. Who are they asking? What do they mean? What's going on? So question everything. Now, I also wanted to show you some ways that you can misuse information, and misconceive or deceive basically people based on graphs. Look at these two different graphs here. These convey the exact same information. But do you notice how this graph, it was done intentionally to make it look like Lincoln School had way less number of girls trying out for basketball than the other two schools. Now, if you look at the actual numbers, it looks like Wilson is about 61, Taft is about 58, and Lincoln is about 50. Those numbers really are not that far apart. But when you cut out, that's what this little jagged part here means, cutting out part of the scale. When you cut out part of the scale and you start at 50, that really makes Lincoln look like it's very, very small in comparison to the others. So somebody might look at this and go, holy cow, maybe we don't need a basketball program at Lincoln if for a girls basketball team if that few students are trying out for it. When if they had just done their scaling different, then you would see, yeah, there are fewer at Lincoln, but it's not that bad. It's not that much. So be careful. Analyze graphs that you see in the newspaper and the magazines and on social media and things like that, and look for ways that they are intentionally trying to deceive you. Now, here's another example. We have two different graphs here that are showing the exact same information. No difference whatsoever, except that the scaling is different. Here we start at 100 and we go up by 50 each time, but it's just little small, they call them tick marks, little small tick marks, from one to the next. So it shows that the number of graduates, you would look at this graph and say, oh, well, yeah, it looks like it peaked in 2014, but it's not really all that much different, from year to year to year. But when they take and start at 130 and go up by increments of 10, you can see that there is a much different picture of what's going on with the number of graduates of this community college from year to year to year. It looks like there's a drastic change from 2014 to 2015. So it really just depends on how information is they're wanting to get it across to you. So don't be deceived. Now, finally, I want to look at a couple of other things here. First of all, I want you to be aware of just flat out errors that people make in creating graphs. This graph, there's something wrong with it. Even though these show the exact same information, they have their bars are just about the exact same. Do you notice what's different from this graph to this graph? It does not have this vertical scale on it. All graphs must have a title no matter what. They must have a vertical axis label, and scaling. This one does. It has a label here and then scaling here. It has to have a horizontal axis label and scaling. So it needs all of those things in order to be a good graph. And then of course you can mess with the scaling and make it look like things are different. Okay, the last thing I want to show you is a couple of things, and you do see these a lot, especially on different things that I've seen on social media. In USA Today, almost every day, there is some sort of a 3D graph. And 3D graphs are notorious for showing you information incorrectly, making it appear that things are a lot different than what they are. It's just because of the nature of the 3D-ness that it makes it look like here this 27% is so much more than these 23%. I mean, this section of pie looks like it's a lot bigger than this section of pie, which is really not true. It's just the placement of it showing a 3D model in 2D space. So be very, very careful that you don't fall into those traps. Look at their percentages and see, are they really all that different? Or no, not really. They're pretty close. Here's another 3D model, and this is actually the exact same information. They just have used different colors for their bars. So you can see here that the recreation and the private ownership, the 27 and the 23%, are showing you a little bit more accurately the information. But when we're talking about percentages, especially, circle graphs work best. It's just hard to look at a bar graph and see that percentage there. So just be very careful about that.